Morning, you're very welcome to this week's episode of the Signpost webinar series. My name is Cian Condon. I am Outreach Innovation Specialist with Teagasc and also the coordinator of the Teagasc Connected programme. This morning, the focus is all on slurry, how it's managed right the way from the yard out onto the land and hopefully protecting our watercourses. I'm joined this morning and a slight change from our billing. Unfortunately, Francis Bly wasn't able to make it this morning, so I'm joined by Donal McCabe here, who is Dry-Stack Advisor in the Longford Roscommon region, but also Health and Safety Coordinator for that region. And also by Róisín McManus. And Róisín is an ASSAP Advisor. And ASSAP is the Agricultural Sustainability Support and Advisory Programme. And she's based in Nenagh and County Tipperary. And also by my colleague Meabh O'Hagan, who is fairly regular on here and will be helping out with questions in the background. So without any further ado, I'm going to ask Donal to share his screen and we can get started.
Okay. Yeah, so look, good morning, everyone. Donal McCabe is my name, as Cian said there. So I'm Dry-Stack Advisor, so dealing with dry-stack clients in Longford, based in Longford here, so in the Longford Roscommon region. But also part of my role is Health and Safety Coordinator within the Roscommon Longford Teagasc region as well. So I'll be talking a little bit about the health and safety in regards to slurry spreading this morning. So look, slurry, as most of you are well aware, it's a very potent, very dangerous material. So look, I will just spend a little bit of time highlighting those dangers this morning. Just before I get into the presentation, just to acknowledge Francis Bly. Like Francis would have, as the Teagasc Health and Safety Advisor, he would have put an awful lot of work into this presentation this morning as well. So just acknowledge Francis's work in regard to that. Okay, so I suppose just in terms of some of the key points, if you're thinking about putting out slurry, I know ground conditions at the moment are notoriously poor. But look, the days are getting longer, so if you get a middling good week this time of the year, a lot of farmers' minds could go to spreading slurry again. So look, when you are spreading slurry, just I suppose that the key points would be in terms of the tank opens, just to guard those at all times. That if you're going away with the tanker, to spread the slurry, the cover should be down on that agitation point, because you just don't know who would potentially be wandering around the tank and could potentially fall into it. Before you are considering agitating the slurry, be very conscious of weather conditions. Some of the days now, not yesterday, but was it on Tuesday this week, was a very calm day. On Wednesday it was quite a calm day, very poor for in terms of ventilation. So gases, when they'd come up, they wouldn't be too easily dispersed. So when they're not easily dispersed, obviously they're going to be a lot more potent and lead to a much increased chance in terms of people succumbing to those gases. PTO shafts are a big thing in regard to agitators and also slurry tankers, because if you think about it, those machines, now look, drive shaft covers, don't get me wrong, they're very important with every machine, but those particular machines, you will spend a lot of time standing around those machines. Let's say if you're going, let's just say, to change the direction of the agitator, you will be in very close proximity to the drive shaft. So with those machines in particular, particularly your agitator, look, it would be very important that your PTO shaft cover is in place and that it's in good nick. That if it's worn or damaged, that it is replaced. Warning signs should be in place. Look, those warning signs, they're widely available now online, or a lot of the agri stores will have them. So they should be there, highlighting, I suppose, the dangers of the slurry. There has been a bit of talk in recent years about gas detection systems. Now, gas detection systems, I can see the rationale for them, but big problem. There's two big problems with them that I can see, and that's why they're not really recommended. The first problem with the gas detection system, if a person is agitating slurry and they think, well, look, I'm wearing one of these gas detection systems, so if there's a danger of some of the slurry gases inhibiting me, which when we go into more detail on the gases now shortly, look, the gas detection system will alert me, but that may not be the case. And look, for two reasons. The main reason being the gas that comes up through slurry, that can be entrapped, within crusts, and just can be released all of a sudden. So the detection system could be showing up nothing, and then just in a matter of seconds, then be showing a lethal dose of gases. So look, that'd be one reason. Look, the other reason would be you can't be 100% sure that it's definitely working. And I suppose the thinking on people that are using the gas detection systems, there is the possibility that they could be lulled into a false sense of security and maybe be doing things that if they hadn't the gas detection system, that they'd say, well, no, look, I won't take the chance on that, but I have this gas detection system now, so I'm okay to walk around the slats, or I'm okay to be looking into the agitation point. So it's look, generally the gas detection systems, look, Teagasc wouldn't be recommending them from a health and safety perspective. Look, it's important that you're aware to never enter a tank. So never enter a tank, even if that tank is empty, because there could be gas that's trapped within that tank. And look, I suppose the big dangers associated with a tank is the numerous gases that are inside that tank. So you have your hydrogen sulfide, you have your carbon dioxide, you have your methane, your ammonia. And also, if you think about it too, you have a lack of oxygen in the tanks. So the oxygen, if you think of a tank in terms of the way it's designed, obviously most of them, a lot of the slatted tanks naturally have slats above them. So the slats are kind of narrow enough openings so that the cattle can walk on them. And then the other surrounds are just big mass concrete walls. So they're not a place where you'd have a lot of oxygen naturally. And then when you combine these potent gases, which are heavier, they'll deplete the oxygen even further, particularly when agitation starts. When agitation starts, the oxygen in those tanks will go down to very little or nearly none. So in terms of the hydrogen sulfide, then, so the normal occupational exposure limit for hydrogen sulfide, so a kind of a world guidance on that is 10 parts per million for 15 minutes for anyone working on it. But in the initial agitation, excuse me, that can be up to 1,000 parts per million released. So that's rapidly lethal. So at low levels, you will detect a rotten egg smell when there's low levels of hydrogen sulfide. But when the levels increase, that smell, it won't be detected anymore. And as I say, it can be fatal within seconds. So it just poses a massive risk. Levels will drop within 30 minutes with air movement. So particularly within the first 30 minutes, and I will go into a small bit of more detail on this shortly, but people shouldn't be in sheds. Cattle shouldn't be in sheds either. And even just to think, because some people will think of the sheds themselves, but I know there has been cases, even a case in County Longford there in the last couple of years, where the gas has actually travelled up through a pipe that was discharging effluent into the tank from another shed, and the people that was there, that had a very lucky escape with slurry gas that came in. So just think of, well, look at, okay, well, I'm not going to go in the shed itself, but is there any other buildings at risk, that could be close to this, where the slurry gas could enter. Just in terms of slurry movement safety and road safety, look, you're dealing with, when you're putting out slurry, you're dealing with very large machines. So those, your carrying machines, pipes, high pressure. Look, you're crossing roads. There is the potential there for, look, those pipes, particularly looking in biblical systems and with tankers for the slurry to be released and cause a lot of injuries potentially to people that might be nearby, or even road safety issues as well. The center of gravity and will change due to the weight of trailing shoes as well. So in terms of the trailing shoes and the dribble bar, there has been a derogation announced there that if your ground is sloping, have an average incline of more than 20% for grassland and 15% for tillage and other land, that there's a derogation again that you don't have to use the dribble bar, the trailing shoe in those situations, just due to the danger of the weight distribution when you're using the trailing shoe and dribble bar, because they'll extend, obviously in a lot of cases, a large distance out from the tank, so it can pose a big danger in terms of overturning. Hygiene can be critical as well, so always keep hygiene to the fore in terms of your PPE and your gloves and that. Look, there's an awful lot of zoonotic diseases that can be picked up from slurry. You have your E. coli, Salmonella, Listeria, Cryptosporidium as well. So be very conscious of hygiene. You don't want to be infecting yourself with what might be in the slurry. Have washing facilities available. So a drum of water at the minimum, just that if you're out and about, that you can kind of wash yourself off fairly quickly if you do get slurry on you, and that you carry a first aid box at all times. Look, it's very important, and I know Róisín is going to go into a bit more detail on this, I'm sure, in her presentation. Adequate capacity for slurry and dairy washings. Like a lot of farmers, I won't say a lot of farmers, but some farmers, that they're under pressure to go out with slurry as soon as the slurry spreading season opens. And look, when they're under pressure to go out, they're possibly spreading slurry in conditions, in some cases, that may not be suitable. Look, the ideal would be to spread slurry when the grass is growing and livestock are outdoors, because, as I mentioned earlier, spreading slurry when there is cattle inside. Like, if you think about it, if you leave the cattle in the shed and you're agitating the slurry and the cattle go down, like, you're left in a horrid predicament then. Every 5-year being will be telling you to go in and try and move those cattle and get them out. But if you do that, obviously there's a very high likelihood that you'll go down yourself, and that someone coming in after you may go down as well, which unfortunately has happened, as we all know, in many situations. So the easiest thing to avoid that is to not have the cattle in the shed in the first place. Look, I know I accept why farmers leave them in. There can be difficulties in terms of letting them out, in terms of penning around the yard, but there is grant 60% rate of grant aid for penning facilities outside yards, in terms of cattle handling facilities, and also for aeration systems as well, which is in this slide here. So look, the message really has to be: never agitate slurry when cattle are present in the field. That's why I suppose the simplest thing is, if you have enough storage in place, plan that where possible. And I know, look, with weather and that, it doesn't always happen, but plan that the slurry is going out when the cattle are gone out. Let's say for first cut silage or that. And look, the only way you'll aim for that really is to have enough slurry storage in place on the farm, and just to use the TAMS funding that is available for, look, there's funding for, as I was saying, for aeration systems, circulation pipes, for penning as well, for cattle handling penning, and for obviously new slurry storage facilities as well. So look, just to finish off, there is, I'm not going to play this video now just in the interest of time, but there is a very good video there that was produced on managing farm safety and health, video series there on slurry safety. So I would encourage all of you just to put that into Google and just to have a watch of that video. Look, it's very informative. So look, that's all for me for now. Look, I'd be happy to answer any questions later.
Okay, thanks very much, Donal. As Donal mentioned there, he's glad to answer questions. And same as always, we hope to keep the webinar as interactive as possible. So at the bottom of your screen, you'll see a Q&A function. So please feel free to send in any questions you may have on Donal's or on Róisín's upcoming presentation over the next short while. And we'll allow some time at the end and hopefully get through them. Thanks very much. Thanks, Róisín.
Morning, everyone. So my name is Róisín McManus, and I'm the ASSAP Advisor with Teagasc and Tipperary. So as Cian said at the start, the ASSAP programme, it's the Agricultural Sustainability Support and Advisory Programme. And that programme has been running now since 2018. So essentially the role of an ASSAP Advisor is to provide farmers with a free and confidential advisory service focused on improving water quality across Ireland. So this involves working directly with farmers on a one-to-one basis to develop tailored site-specific solutions to reduce the risk of agricultural impacts on water quality. So look, Donal touched on, I suppose, the agitation side and health and safety. So now I'm going to touch on, I suppose, the spreading of slurry and how you can minimise losses to water. The outline of my presentation, I'm going to go through slurry composition and value. I'm going to touch on slurry storage capacity, maximising slurry nutrient use, actions that we can take to minimise environmental losses, and then I'm going to finish up with a summary. So I suppose with the Water Framework Directive target that we have to achieve at least good status for all water bodies in Ireland by 2027, significant emphasis has been placed on targeted actions. In response to this, the Better Farming for Water campaign was launched to deliver bespoke water quality improvements plan across 8 priority river catchments. So this initiative very much builds on the existing programs that we have in place, like, your ASSAP program, the Better Farming for Water EIP, the Agricultural Catchments program, and Acres. So the 8 catchments identified under the campaign are the Barrow, the Boyne, the Nore, the Slaney, the Blackwater, the Bandon and Lee, and the Suir catchment. And I suppose to make it more relevant to the region that I'm working in, the Suir catchment Better Farming for Water Action Plan was launched on the 29th of January this year. So this is a whole industry initiative led by Teagasc in collaboration with ARA Tip Co-op, ABP, and other industry stakeholders within this catchment. So the campaign is designed to support farmers in improving water quality in areas where agriculture has been identified as a pressure. So the overall objective really of this campaign is to accelerate the adoption of 8 key actions across 3 critical management areas. So on the slide there, I have, there's 3 critical management areas. So, nutrient management, farmyard management, and land management. And I suppose for the purpose of today's presentation, I'm going to focus on actions 1 to 4. So these include number 1, reducing purchased nitrogen and phosphorus surplus per hectare. Number 2, ensuring optimal soil fertility, particularly in relation to lime, phosphorus, and potassium. Applying fertiliser and organic manure at appropriate times and under suitable conditions. And finally, Donal mentioned it previously, ensuring adequate slurry storage and soil to water capacity. So I suppose when we talk about slurry, we really need to start with one key point. It's a valuable fertiliser. Its value is very much dictated by the nutrient content, and more importantly, by how well we utilise those nutrients on farm. So with fertiliser being where it is now, getting maximum value from slurry has never been more important. On many farms now, slurry isn't just a byproduct, it's a central part of the nutrient plan. The challenge, though, is that the value of slurry can largely vary. So its nutrient content varies depending on obviously the type of animal, the diet of that animal, the storage system, and how much water is being added, either through rainfall or, for example, dairy washings mixing with the slurry. So if we treat all our slurry as the same value, we're either leaving money behind or we're risking over application. So one practical step that you can take to deal with that variability is to measure it. So a slurry hydrometer, for example, it's a simple on-farm tool that gives you a density reading, which you compare to reference tables like what I've attached here, to estimate the nitrogen, phosphorus, and potassium content of the sample. So the use of a hydrometer, the big advantage really with that is speed. You can test quickly and you can repeat it throughout the spreading season. You know, because slurry can consistently change between tanks and even between loads. But I suppose if you're looking for more precision, you can take various different samples, send it off for lab analysis, and this will finely tune, you know, your fertilizer planning. But I suppose it's important that whatever method you are using, you know, the sampling process is critical. So the slurry must be fully agitated before you take a sample. If the slurry isn't properly mixed, the numbers won't reflect what you're actually spreading. So a simple and safe method is to agitate thoroughly, draw up with a full load, draw up a full load with the vacuum tanker, and then take the sample from the tanker filling point. That way you're sampling a well-mixed slurry, not just one layer. And of course, agitation safely is absolutely critical, as Donal mentioned. Now, if we take a look at the table that I've attached in the slide, the message, it's very clear. As your dry matter increases, your nutrient concentration also increases. So on the far left here, I have the dry matter percentage. So if you look at 2% there, you know, it's watery slurry. You're looking at 4 units of nitrogen, 2 units of phosphorus, and 13 for potassium. So it's relatively low. But look, by the time you get to your typical 6% dry matter cattle slurry, it's your 9 units of N, 5 for phosphorus, and 32 for K. So your 9, 5, 32 per units per 1,000 gallons. You know, and again, as it increases, you know, the dry matter increases, your nutrient content also increases. So when you put that into practical terms, if you're spreading 3,000 gallons per acre, that's the difference between applying roughly 12 units of nitrogen at 2% dry matter or close to 30 at 7% dry matter. That's not a small difference. That is a completely different fertilizer strategy. So I suppose I'm just going to touch on research that was previously done by William Burchell, and that showed that slurry from uncovered storage facilities tend to have a lower nutrient content because of the extra rainfall collected. So more water lowers the dry matter, and lower dry matter lowers nutrient concentration. And this is very much reflected in this table. So your soil water there below, it's much lower units of N, P, and K per 1,000 gallons. So I suppose that's why I encourage farmers that when you are going testing slurry, test it from a number of different storage systems that you may have on the farm. You know, your roof storage facilities often produce higher dry matter slurry. It's more nutrient dense, and that gives you options. You can target that slurry to ground where high nutrient offtake, you know, so for example, your silage fields. And look, as we're all aware, the cost of transporting and spreading slurry is costly. So if slurry has to be hauled to outblocks or silage ground, it makes sense to move the most nutrient dense slurry available. There's little benefit there in transporting diluted slurry long distances when stronger slurry could deliver a far greater value per load. So I've just attached there a picture of that slurry hydrometer. Look, this slide here is just going to go through the available nutrient content and guide of organic fertilizers. And this was updated in January 2028 or 2026, sorry. And this is basically, you know, they touched on that 6% dry matter cattle slurry, your 9, 5, 32. And that's coming in at a value at the minute of €28 per 1,000 gallons. So when used appropriately, it is a highly valuable source of fertilizer. I suppose the next couple of slides, I'm going to talk about slurry storage capacity. And I suppose before I move on to talking about slurry storage capacity, I want you to think about one word, and that's protection. You know, so protection of valuable nutrients on your farm, protection from spreading when the crop uptake simply just isn't there, protection of the money tied up in slurry, as we've just discussed, and ultimately the protection of water quality from avoidable losses caused by spreading at unsuitable times. I suppose too often slurry storage can be associated with compliance, you know, meeting a requirement and simply in some cases just ticking a box. But I'd encourage you, you know, to look at it differently. Slurry storage capacity is not just about regulations. It's about giving yourself control. It's about protecting nutrients until the crop can actually use them. and it's about protecting water from losses that we know occur when conditions aren't suitable. So with that in mind, so look, slurry storage, it's a critical but often underutilized part of nutrient planning, nutrient management planning. So in 2022, as part of my Walsh Fellow Masters, I carried out research on 40 randomly selected dairy farms in the Teagasc Advisory region to assess their slurry storage capacity. The current figure of 0.33 cubic meters per cow per week for slurry production was used. And look, I suppose it's worth noting that this figure has been in place since the introduction of Ireland's first nitrates action programme in 2006. And I suppose what was striking about the findings was 30% of the farms that I assessed had a storage deficit. So look, they simply didn't have enough storage to comfortably get through the required storage period. A further 36% were technically compliant, but they had very little buffer. So in other words, they were right on the edge. And that's before you even factor in additional volumes like, potentially dairy wash and store-bought slurry, runoff from feed yards, additional rainfall entering uncovered tanks, and water maybe from poorly managed gutters or downpipes. So all of that increases your volume, and increased volume means pressure on storage capacity. So look, I've highlighted in red that from the study that overall 55% of these farms were either non-compliant or at risk of being non-compliant. Now, if you link that to the presentation so far, if storage is tight, spreading decisions become reactive. So you spread because you have to, not because conditions are right or crop demand is there. That increases the risk of nutrient loss, reduced fertilizer value, and it has a major negative impact on water quality. So this slide is really important because it adds another layer to the slurry storage capacity conversation. So this work was carried out by Dr. Pat Toohey between 2023 and 2025, and this assessed slurry and soiled water volumes on 100 representative dairy farms nationally. And the key findings are significant, and they have had an impact on slurry and soiled water regulations. So one of the key findings was that slurry production was found to be 21% higher than the current regulations that are in place. The measured figure was 0.4 cubic meters per cow per week, compared to the current figure we're using at the minute, which is 0.33 cubic meters per cow per week. That alone has major implications for storage design and capacity. I'll use Tipperary, where I am, as an example, which is in Zone A. So you require 16-week storage in Tipperary. That's 1,161 gallons per cow for 16 weeks with the current figure. When you increase that and use the new 0.4 cubic meters per cow per week, that's going to increase to 1,408 gallons per cow for 16 weeks. But I suppose it becomes even more striking when we looked at the soiled water results. So soiled water production was 43% higher than the current regulations that are in place. It measured at 0.3 cubic meters per cow per week compared to the current regulations in place, which is 0.2. So that's a substantial difference. And I suppose it's important that we're all aware of these updated values and we understand that these are going to be enforced from the 1st of October 2028. So look, it's the month of February 2026 now. That gives us a massive window of time now to plan and essentially take action. Look, it's a slow process, but look, it's about, rather waiting until it becomes an urgent problem, take action. So I'd strongly encourage you to sit down with your advisor as soon as, workload allows and assess your current situation for slurry and soil water capacity. Look at what you have now and how it measures up with the new figures and whether, is there improvements that could be made to your existing facilities. Look, if there's one advantage of all the rain we've had over the last couple of weeks, it's probably around being the perfect time to assess your farmyard. So, when there's heavy rainfall, you can see exactly what's happening in your yard in terms of water flow. So you can see where the water is flowing, where it's pooling, and more importantly, where it might be getting into slurry storage when it shouldn't be. You'll quickly spot gutters that aren't working properly, downpipes that need maintenance, or areas where clean water could be kept out of the system with a small change. So look, here's the challenge for you all. So take 10 minutes, over the next couple of days, and when it is raining, and walk your farmyard. Don't wait for a dry day. Go out when the water's moving. And even, I'd strongly encourage you just, from experience doing ASSAP visits, like bring someone else with you, because the farmers in the yard every day, and they don't notice the problems. Bring someone like a family member, a second pair advisor, and small practices. So small practical changes can make a significant difference to storage pressure over the winter. So once you've assessed your situation, then the next step is to put a clear plan in place. That may involve upgrading your storage, improving separation of clean and dirty water, or looking into available grants, as Donal mentioned. And again, it's a slow process, so it's important now to take action. So look, insufficient storage capacity, it's very obvious, it results in slurry application under suboptimal soil and weather conditions, nutrient application to fields with low demand, and reduced nutrient use efficiency. This has an increased risk of losses to water. The advantages of having adequate storage, it enables strategic timing, targeted application, as I mentioned, and look, you're avoiding the spreading and even the moving around of slurry during peak workload periods. So investment in slurry storage infrastructure, so it supports improved nutrient use efficiency and compliance with regulations. It enables flexibility in slurry application scheduling. It delivers long-term financial returns through reduced fertilizer requirements. You can qualify for accelerated capital allowances, and reduces operational pressures during the close period. So look, most of you might have heard about the right place, the right time, the right rate before. It's widely used in nutrient management, and it's a very simple but very powerful framework. And these next couple of slides, I want to look at what that actually means in the context of slurry. Because if we're serious about maximizing slurry nutrient value and protecting water quality at the same time, these three principles really guide how we spread it. So look, taking the first principle, right place, what does that mean for slurry? So look, I've put a table here again of that 6% dry matter cattle slurry. So we're talking about, your 9 units of nitrogen, 5 units of phosphorus, and 32 units of potassium per 1,000 gallons. But look, the key point here, and I've highlighted it in red, is about 80% of that value is coming from phosphorus and potassium, and only about 20% from nitrogen. So when we talk about the right place, we're actually talking about protecting, that €28 per 1,000 gallons. If you spread, that 9-5-32 on index 4 soils that don't need phosphorus, that's money lost. The crop can't utilize the nutrient, and you're effectively wasting a large proportion of that fertilizer value, while also increasing the environmental risk. On the other hand, targeting index 1 and 2 soils in suitable conditions, obviously, is where you get the best response and the best return. So it means consulting with your soil samples. When's the last time you have soil sampled? If you have soil sampled, are you looking at your soil samples? Do you have a nutrient management plan in place? Is there a line requirement? Because, is the soil pH limiting your nutrient uptake? Because even if the slurry, even if it's good slurry, it's not going to perform if the soil chemistry isn't right. So in summary, really, it's about matching slurry to fields that actually need P and K. It's avoiding high index soils and targeting nutrient dense slurry where demand is greatest. So next slide, you talk about the right time and the right rate. When is the right time, and what is the right rate? So, early in the season, late January into February, as you can see on the grass growth curve here, grass growth, it's relatively low. We all know that soil temperatures are lower, the growth is slower, and total nitrogen demand over a 4-week period is limited. In that situation, like if you don't have the capacity to be flexible with your spreading, you're just going to have to, look at your light application rates. For example, around your 1,000 gallons per hectare, it's more appropriate. That type of rate broadly matches early season demand without oversupplying nitrogen. I suppose if you were to supply 2,500 to 3,000 gallons per acre at this stage, you're applying more nitrogen than the crop uses over that 4-week period. And when nitrogen isn't taken up by the plant, efficiency drops and the risk of losses to water increases. But look, as you can see from the chart, when we move down into our stronger growth periods, typically through March and especially into April, things change very quick. Soil temperature rises, your days are getting longer and growth rates lift significantly. So grass demand for nitrogen over a 4-week period increases sharply. And that's when higher slurry rates can make sense, because the crop has the capacity to use more nitrogen. The key is that application rate should rise in line with growth and uptake, not ahead of it. And I suppose right time means spreading when conditions are suitable and growth is building. When we talk about the right rate, it's important that we're adjusting how much you spread depend on where you are in the growing season. Lighter rates in the early spring, as I said, and matching higher rates to stronger growth later on. And look, that's effectively how we improve nitrogen efficiency, protect water quality, and make sure the nutrients in the slurry are actually captured by the crop. So this slide shows our grass curve across the season, but more importantly, it separates out well-drained soils and poorly drained soils. And that's critical when we're thinking about slurry timing. If you look at the start of the year, January and February, we all know that growth is a bit lower and across all soil types. And it's marked here as a risky period. During this time, your soils are often cold and wet, nitrogen uptake is limited, and the risk of leaching and denitrification is high. So even if slurry is applied, the crop simply isn't in a position to use it efficiently. But as we move into March and especially April, growth increases rapidly, particularly on well-drained soils. Your soil temperature is rising, as I mentioned, the days are getting longer and nutrient uptake improves. This is where slurry can really deliver value, now provided conditions are suitable. You'll notice that well-drained soils respond earlier in the spring and maintain growth more consistently, whereas your poorly drained soils are slower to respond and can drop off more quickly again in the autumn. And I suppose that comes to the second risky period in autumn. So growth declines, and soil conditions deteriorate. And again, the risk of nitrogen loss increases. So applying slurry during this window carries a much higher environmental risk and lower nutrient efficiency. So I suppose overall, I use this slide to reinforce the important points. Right time isn't just about the calendar, it's about soil type, soil conditions, and growth rate. Well-drained fields may be suitable in the spring, but poorly drained fields, they require more caution. And that's where tools like your pit maps and soil knowledge comes in. They'll help you guide decisions based on the actual growth rate rather than your dates. So ultimately aligning slurry application with active growth periods and avoiding those high risk windows. It's key to protecting this high nutrient value and water quality, of course. Look, so the actions to minimize environmental losses. Look, there's a lot of actions, and we could talk about this on a whole separate webinar. So look, low emission slurry spreading. So, this significantly improves nitrogen efficiency and reduces losses. The soil moisture content. So, avoid spreading on saturated soils. If the soil can't absorb it, obviously the risk then of runoff increases immediately. Avoid if heavy rainfall forecasted. So I suppose just to highlight this point and how it actually feeds into our GAP regulations. So within the GAP regulations, it states that slurry, fertilizer or soil water must not be applied where heavy rain is forecasted within 48 hours. Now it's important that we're clear on what heavy rain actually means. So in this context, heavy rain is defined as rainfall that meets the criteria for yellow, orange or red rainfall issued by Met Éireann. So this isn't just a judgment call, it's linked directly to official weather warnings. And that's something I think many of us aren't fully aware of. If a rainfall warning is in place for your area, spreading within that 48-hour window would not be compliant. It really reinforces the importance of checking the weather forecast carefully before spreading, not just looking up at the sky. You need to be checking Met Éireann updates. Again, this links back to storage capacity. Adequate storage capacity gives you the flexibility to delay spreading when those warnings are issued, rather than being forced to spread ahead of bad weather. So matching your slurry and fertilizer applications to grass demand, as I mentioned, and then the use of your EPA pit maps, either on the catchment's website or on NMP online, and I'll go into that further. So you're adhering to buffer zones. So, while buffers are basic regulation, these buffers, they play a very important role in reducing nutrient runoff, sediment loss, and pollution entering water courses. So when they are properly adhered to, they can have a significant impact on minimizing environmental loss. So I've just attached a table here, which will go through, varying between 5 and 200 meters of buffers that you need to maintain when spreading organic manure. I suppose going over and beyond the minimum gap requirements through enhanced measures under the Farming for Water EIP, for example, can further strengthen water protection. So, going with a riparian buffer zone along a water course of 3 meters, for example, and sowing trees within this buffer to help with nutrient uptake, which I've attached in this photo here on the right. And finally, as I mentioned, make use of the tools in the nutrient management software. There's a soil fertility map there, and it'll help guide decisions based on risk, and also water quality sensitivity. So look, this map allows you here to identify fields that need lime, see which fields are index 1 or 2 for P and K, and identify high index fields which slurry should be avoided in. So people, you hear the term PIP maps, that's your pollution impact potential maps. These maps are available on the NMP software, but I've also linked, if you don't have access to NMP online, you can go on to catchments.ie and access these maps. So basically, these are the PIP maps for nitrate. So, so it focuses on the areas where nitrate loss to water is the highest risk. So, and this can help to determine, timing decisions, rate decisions, and whether, the right time and the right rate. So, PIP rank 1, so the darker the purple, the higher the risk of nitrate loss. And these maps are actually quite useful as well, because it's included the water quality status, maybe of your local water body. So in this example I've used here, it's moderate status because it's coming up as yellow. These are your PIP maps for phosphorus. So again, the darker the blue, so PIP rank 1, the more risk of phosphorus being an issue of loss to water. So again, it's identified the water body on the farm, it's moderate status, and those little dots really are your delivery points. So points along that water course where there's the highest risk of phosphorus loss. We talk about overland flow, so maintaining those, simple gap, the gap regulations, your buffers, or looking at measures that can go over and beyond to minimize the risk.
Róisín, just about 2 minutes there, please, if that's okay.
So look, in summary now, slurry is one of the most valuable nutrients. Good storage protects more than just your compliance. It gives you flexibility, protects your nutrient, and protects water quality. And look, your right place, your right time, and look, again, make use of those the maps that are available. So that's it. Thanks a million for listening.
That's great. Thanks, Róisín. If you want to stop sharing there, please. I know there's a good few questions in already. So again, I'd like to invite anyone out there. We'll try to get through as many questions and answers as possible. So I'll go straight to Meabh. Meabh, do you want to open up the questions there, please?
Yeah, look at two very interesting presentations, and in particular, Róisín, I think a lot of the topics that you're covering there are extremely relevant at the minute. A lot of ground obviously waterlogged and tanks getting very full. So I guess just two things. A question that often comes, from farmers out in the ground and stuff like that, is talking about the farming by dates and why do we need the closed period if ground conditions were better in December, blah blah blah. Can you just maybe give us a quick idea as to like why the closed period is in place and the importance of that for water quality, and then also just maybe touch on where we're at the minute in terms of slurry spreading in ground conditions right now, and how farmers can protect that water quality in such difficult conditions.
Yeah, so firstly, I suppose to touch on the closed period and why the closed period is there. Look, the research is there, and like during the close period, the days are getting shorter. We've less daylight, soil temperatures. It's very clear that soil temperatures are dropping, so the uptake just wouldn't be there. And even if you take your front lawn or your back lawn, for example, like, you're not getting growth, like, the grass isn't growing, overhead it might be dry, but the temperatures aren't there, to uptake and get the best value out of that slurry. I suppose the second part of that question was about, adhering to certain sorry, Meabh, the second part of that.
Yeah, sorry, just around like I guess the issue with waterlogged soils across the country and tanks becoming full, people maybe coming under that bit of pressure. Just there's questions there around, one of the questions was coming in saying that some of the weather warnings and stuff and what happened in reality maybe didn't link up as much, and people were caught a little bit offhand. Going forward, like, what do you see in terms of that extreme weather, and do you see a situation basically where the likes of the soil moisture capacity is going to be linked with how farmers can manage their slurry, and maybe how it's regulated as well?
I think, like I touched on the regulations that are coming from the 1st of October 2028, and I think it's definitely relevant. Like, on paper, for example, Meabh, you might be compliant, but you're not getting to the end of the close period because you're using that 0.33 cubic meters per cow per week. And I suppose, production has upped, cow type has changed, and we're producing more slurry. So I suppose, so it's looking at, now with them regulations that are coming down the line, making a plan, and we can learn a lot from this year. We can learn a lot in that, just having enough, it's just not, good enough really, because we need that extra buffer. So, having maybe 20 to 20% of a buffer, so that we can tailor then the flexibility around spreading, because, we are getting more frequent heavy rainfall in the springs, and we need to have that flexibility of spreading. I know when tanks are filling, you have no choice, you have to go out. But I suppose we can learn a lot from this year in that, planning maybe for the following year to give yourself more flexibility, really. So we're not going out in those dramatic heavy rainfalls. In terms of around the regulation changing, I don't know. I suppose further research is required in this area. I can only really talk around the research that's been done in terms of requirement for slurry and soil water, but in terms of calendar farming change, I can't see that changing anytime soon anyway. But I suppose we can only really control what we have now at the minute, and that's really to try and look at what we have versus the way we were this spring in terms of capacity.
I remember someone saying, I don't know who it was that said before, some people see the slurry storage requirements kind of as the same way that they see speed limits, that it's not just that you're trying to just hit that number, they see a speed limit as a target, they see the slurry storage requirements as a target. It's not that's, that's either the limit or it's the minimum requirement of what you have to have on the farm. That doesn't mean that in reality it's going to be sufficient for what you need to leave yourself comfortable with it, I guess. And you mentioned as well, and I might actually put this question to you, Donal, as well, in terms of people who are looking at maybe getting TAMS grants for investing in slurry storage. And just there is, coming back to the health and safety side of things, there is particular requirements there about external agitation points and stuff like that. Would you just briefly go through what's the requirements of somebody who was hoping to avail of TAMS grants for slurry storage?
Yes, Meabh. So in terms of the TAMS grants, look, you won't get any TAMS grant aid on a shed or a tank unless there's external agitation points for the investment, and that's obviously for safety reasons. Like internal agitation points, look, they're very dangerous. There's no point in otherwise. That really look, and I know they are being used on a lot of older tanks, especially, but they provide a massive danger because a covered agitation point, like I mentioned, the slurry gases there earlier on, you're extremely vulnerable in that sort of environment using internal agitation points. So look, I know you made reference to the grant aid there, like for slurry storage tanks. That there's a 60% rate of grant aid there now for those investments. So it is, I know even in my role as a dry stock advisor, you can see a lot more farmers thankfully interested now in looking at putting more slurry storage on their farm. They're availing of that extra grant aid, which for a lot of them previously was only 40%. So that's welcome. Like, that is positive. That extra rate of grant aid, it is working. Look, the big hindrance, unfortunately, for some farmers is that if they're not seen as nitrates compliant currently, they won't be able to apply for that TAMS funding. So look, that is an issue that potentially some farmers that need it the most may not be in a position to apply for TAMS funding on it.
I think it maybe just highlights as well, Róisín discussed the new regulations coming into play in 2028, so I think it really highlights the need for people who, if they're going to be left with, too tight on slurry storage with the new regulations, that now is the time really to start thinking about putting in an application for grant aid in order to get that extra capacity in place before those regulations come in. Because as you said, if you're not compliant, you can't get approval.
And even just assessing what you currently have, in terms of, I see it in a lot of farmyards, there's clean water getting into slurry tanks that can be minimized, and trying to, work on what you have and compare it to the new changes coming down the line, and then put a plan in place. But yeah, it's really important to, to be acting on that. Like, if you're calving cows now, I know it's a busy time, but once that workload slows down, you contact your advisor, get them out, and to do a slurry storage assessment and get the ball rolling, essentially. Because I know you're thinking, oh, it's the 1st of October 2028, but it doesn't be long rolling around, and with the length it can take, for TAMS approval, if planning permission is required, in your case, but that can all take time,
Yeah, so to try and be proactive about it. And then again, just following on from my earlier questions, which is, well, Róisín, like, there's a question coming, well, first of all, about slurry sampling and where to get it sampled. So the labs that people would normally go to for soil sampling, do they also do slurry sampling?
Yeah, so I'd say, first of all, maybe contact them and ask, is it FBA? They do sampling? There's different approved labs. But I suppose even if you contact the person that's doing your silage samples, and see, do they also do slurry samples? And Donal, you might know, is there anywhere that does slurry sampling? But just, I touched on, when you're taking the slurry sample, not just, take it correctly and make sure that it's well agitated. Take it from a couple of different, take, 2 or 3, 4, or even 4 samples, from different, tanks that are roofed, tanks that have a lot of water entering, from a collecting yard, for example. Take a few different samples. And there is funding. There is funding there. I suppose if you're a farmer that's went through the Farming for Water EIP, there is funding there to get samples taken.
Yeah, and I think most of those larger accredited labs that they do the not just slurry, but different types of manure testing as well, or sludges or things. And I know when I worked back up in the east, I worked with a group of tillage farmers, and they used to regularly test nearly all the slurries that were coming into the farm. They imported poultry manures and stuff like that for use on tillage crops, and rather than use the book figures, they were very careful about using what was actually in the manures themselves.
And even just on that, I think that's especially useful for farmers who find themselves with a tight phosphorus allowance.
Sorry, I'm not hearing you clearly, Meabh. I just wondered, can Róisín or
go again there, Meabh?
Yeah.
Yeah,
Yeah.
you're back
better now.
Can you hear me? Yeah, sorry, I was just saying, you know, the importance of slurry sampling, probably especially important as well for farmers who find themselves tight on phosphorus allowance as well, to make sure that, you know, if they do have index 1 or 2 soils on the farm, but they have a low allowance overall, that if they're trying to address that, if they get the slurry sample, they'll be able to target the higher P slurry to those areas too.
We'll try and take a couple of more questions now before we finish. I know there's a few there about, and a lot of the questions are driven given the weather we've had for the past month, 5 weeks, whatever it runs into this stage. I know there's there about firstly, I suppose who's responsible for the implementation or the monitoring of whether practices are done correctly? Who's judging that part of things? And then maybe might look there about the one on the ground conditions maybe as well. So what do you think, Róisín? Who's responsible for implementing the rules, the legislation with regard to water quality and spreading dates and so on?
So I suppose that's part of your good agricultural practice under the Department of Agriculture. So I suppose that they're the ones that have rolled out the nitrates action program, the 6 nitrates action program. So they're responsible for that. And then in relation to spreading conditions, Cian, what do you mean by that? The ground conditions?
Yeah, there was a question that came in there, Róisín, about you know, should there be leniency showed around, you know, the methods of spreading given the ground conditions at the minute, in terms of rain guns and things like that have been obviously ruled out from water quality protection. You know, they're asking, should there be leniency shown on that?
I suppose no, I can't see leniency coming in that area, but I suppose it's about just looking at your capacity and having that extra buffer so we can plan for these rainfall events and weather conditions that, you know, it's like it's been very difficult on farm this year, but you know, we don't want to make the same mistake next year and not have that buffer in place, and so we can target slurry in fields that's going to uptake the nutrients. Like, you know, you don't want to be going out with slurry and waterlogged soils, but I completely understand that you know, storage hasn't allowed you to target that application. So look, we can learn a lot, as I said, from this year, and we can plan to have that extra buffer next year so we can deal with if a rainfall event comes like this again.
Yeah, and I think, you know, we see obviously the likes of the county councils and stuff who are also implementing those gap regulations. Like, they've really upped the number of inspections, I know, up around this part of the country as well. So just to be aware of that, and the reason for that is because we are trying to hit those targets of improving water quality across the country, and it's very important that we stay, you know, that we stay moving towards those targets, and also that we're very aware. We were lucky in that we've gotten an extension to our nitrates derogation as well, and it's really important that we're all, you know, yes, there's difficult conditions, but we still need to be all rowing behind what it's going to take to improve water quality and try and retain that derogation if possible. There was just one other point there as well, but I know we're just tight on time there, Cian, but there was a question that came in about is there a need for a traffic light approach for spreading slurry in times of rain events to avoid the waste of resources and runoff pollution. Róisín, do you think that's something that would be useful for farmers?
I suppose there was a traffic light system, kind of a tool developed by Teagasc years ago, and I think it's available. I suppose if you go onto the Teagasc website, and it basically gets you to look at, you know, the soil moisture content, you know, looking at your PIP maps, again, heavy rainfall forecasted in the next 48 hours, you know, so yeah, there is a tool developed there. I suppose it's just about, I suppose, as advisors, we're trying to now, you know, use those tools at like discussion groups and one-to-one visits to re-emphasize, you know, when, you know, your traffic light system is in place, you know, your red light, yellow and green light. So, you know, but yeah, there is a tool there. Maybe you might be familiar with that tool yourself, but maybe that's something I probably should have put in the presentation. But yeah, there is a tool there. Yeah.
it's good to have kind of practical on the ground stuff to use for this. And I know that Cian Condon down in Johnstown Castle is in the very early stages of developing an app that will take into account farmer location and soil type and local weather forecasts to build on that tool that you've mentioned, Róisín. So it's still in the early stages of development, but it's looking like it'll be a very useful thing for farmers to be able to make good decisions around slurry spreading.
Okay, we are running over, so I'm going to call a halt things. I'm going to get Meabh to put something up on the screen here just in a moment, but I just want to apologize. There is a huge number of questions after coming in, and we simply didn't have time to go through them all. Just before we wrap things up, Meabh, there's just one thing we want to bring to people's attention. If you can throw it up on screen.
Yeah.
Yeah, that's good.
So I just want to go through the Teagasc FBD Environmental Sustainability Awards for this year have officially been launched. The deadline is coming up at the end of February. So anybody who is interested can put forward an application, or if you know of any farmers who you think would be suitable candidates, to please make them aware of it. So there is a number of different categories that they can apply under, and a wide range of prize funding available for them as well. So definitely worth any farmers that you think would be suitable to make them aware of the deadline of the 27th of February, please.
That's great. Thanks very much, Meabh, if you want to take that down. So that's it. Thanks a million to everyone for joining us today. We're a few minutes over time, but we got through a lot of stuff. I'd like to thank Donal and Róisín, of course, for their presentations and for taking time with the questions, and to Meabh here for handling a lot of information as it came in. And of course to our team in the background who help make this webinar possible every week. That's it for today. Thanks to everyone for joining us. We hope you can do so next week. And have a great weekend. Thanks very much.